Hello Year 10, it's just Miss Cavilla Perkins here, just hoping that you're all very well. I just thought I would catch up on last lesson's work with a few questions and answers, and then launch this week's learning on physical landscapes of the UK. Now hopefully you're choosing between PowerPoints or textbook or a bit of both, whichever suits you. You've also got your glossary and your tick list for this topic. It's a very lovely topic, so we'll start by just having a little look at the image in front of us. Now this is a physical map of the UK, obviously showing the contrasting relief, so the shape of the land. Now you can clearly see from west to east this massively changes, because you can see the sort of brown beigey colour areas are our large mountain ranges like the Grampian Mountains, where there is very, very hard resistant geology to erosion, so therefore it leaves us these very dramatic and mountainous landscapes. And then obviously you can see the lighter green areas, which are the flatter areas, which must have a more or a less resistant geology to erosion, so highly eroded. In fact, you've got the fens that actually sit below sea level, so often get flooded. So wow, what a country we have, what an island we have. Complex river systems and networks, mountain ranges. So we'll move on to the next area, which is waves. So we're looking at this concept of waves because we start with looking at the coast of the UK. Waves are very interesting. Now, when they start out to sea, they have a very circular orbit in deep ocean water. And as they get closer to the continental shelf or the seabed, the friction turns this circular motion more orbital. And obviously it becomes then more elliptical and oval shaped due to the friction with the seabed. And then eventually these waves will crash. Now, depending on how strong the waves are will depend on the fetch, which is the distance and the amount of wind and energy that these waves have picked up. So therefore waves coming off the Atlantic Ocean may have travelled hundreds of miles to the UK and can be very, very erosive and destructive. So just quickly, we'll go over the two wave types you met last week. So first of all, you've got your constructive waves. Now these waves surge up the beach and they're very powerful in their swash, so coming up the beach. So they carry and deposit large materials all the way up the beach. And I like to think of it as constructive waves build up the beach, basically. They construct it. And obviously then they have a slightly gentler backwash, so therefore they're building up and depositing material on the beach. And what that might look like here is a nice gentle beach with lots of deposits, as seen here. Destructive, on the other hand, these can be formed by local storms or a very long fetch that the wave has been able to pick up a lot of energy. Now these actually destroy the beach. They're often closely spaced apart as opposed to constructive waves, which are wider, and they will have a weaker swash but a very strong backwash, which will actually bring the material back down the beach. And it also takes a lot of the material with it, and it leaves a very steep beach, which I'll show you an image of now, like this, with a lot of heavier, larger materials like pebbles because of that strength of the waves. Okay, so on to this week. So it's week 2 of physical landscapes of the UK. So you can have reference to the textbook pages 94 and 95. And what we'll be looking at is the processes of weathering on the coast and how they are linked to mass movement. So 2 definitions for you then. So weathering is the weakening or decay of rocks, and that is when they are in situ. So the rock itself isn't actually moving, it's the weather and the conditions around the rock that are actually causing it to weaken. And this leads on to the mass movement. So due to gravity, this is the movement of boulders and weakened rock that will then dislodge from the cliff. So in a second you can pause the video here to watch the short YouTube clip on your PowerPoint, But we're going to look at the difference between weathering and erosion. So weathering, like I said, is the breaking down of rocks in situ, so it's the weakening of them. And the erosion is when they are actually carried away, so whether it be through rain or wind or waves. Okay, so there are 3 types of weathering, and you're going to pause the video here so you can match them up. Here are your answers. So biological, this is the action of plants and animals. Mechanical, this is the breaking down of rocks due to the weather conditions, so like freeze thaw and salt weathering. And then chemical is that reaction with the rainwater from the rocks, which we'll come back to. So I'd like you to have a go at matching up the different images with with the images with the definitions, and you'll see the answers as we go through. So this is freeze thaw weathering. Now, when water freezes, it actually increases in capacity by about 8%. So it gets bigger by 8%. So when water goes into a crack and then freezes, it's actually going to enlarge the space and thus crack the area. So when it thaws, the rock is weakened and enlarged. So that's a very important example of mechanical weathering. Biological weathering, you probably only have to look outside in your pavements, where you will actually see the power of roots and plant growth that can actually crack through surfaces even as hard as cement and concrete. And then you have your chemical weathering. So you've probably seen this on buildings as well, where there might be carbon within the water or acids within rainwater that can actually weaken and dissolve rocks. So if you're going through the textbook as well, make some notes obviously on that too, but we're now going to have a little look here at this idea of mass movement. So you can see an excellent example of this here at Holbeck Hall in Scarborough. So this area was moistened and lubricated by extensive rainfall, and then led to gravity slumping this material down. Now, there are 4 types of mass movement. There are rock falls, usually caused by freeze thaw. There are landslides, which can be very dangerous to local populations. So that's when blocks literally slide down the hill after weakening through weathering. You can have mud flows, like you've just seen on the previous example, where the saturated wet soil will actually weaken and slump down and slide down the slope. And then you can have rotational slip, which is the slumping of saturated soils on a slightly curved surface. So I'd like you to go through each one of these and create yourself an example with them as well and see them in action there. So rockfall is very interesting because actually the build-up of material can actually form a scree slope, which actually then will protect the cliff from further erosion. Landslides, a good example here of Lyme Regis in Dorset, where the area of the rock, the geology has been weakened and then slides. You've then got some rotational slumping here. So have a go at the textbook questions and check my model answers to help you with those. Now moving on to page 96, and now we're going to look at the processes of erosion at the coast and how these can impact the landforms at the coastlines. So you've got 5 different processes of erosion, so it might be an idea to pause the video and create yourself some flashcards, for instance, so you can remember these. These are, of course, on the keywords list I sent you last week also. So there's a few videos. You might want to just pause for a second here and watch a couple of videos that will show these different processes of erosion in action. So first we've got hydraulic actions. That's the sheer force of the water hitting against the cliff and weakening the already weakened and weathered rocks even further. You've then got abrasion, which is often likened to a sandpaper effect, to which the water is carrying sharp fragments of rock which will further erode the cliff face that they are hitting on. You have attrition, which is when you've got lots of materials within the waves that are moving and hitting against each other, and they are actually breaking and smoothing each other down as they are hitting against each other, but they are also hitting against the cliff surface and further eroding it. You've then got solution, which is the acids in the salt water that are dissolving some of the cliff faces and the materials they hit against, such as chalk or limestone. They're very susceptible to solution. So I want you to think about what this might look like, because some coastlines are far more susceptible to erosion than others, depending on how resistant or less resistant that their geology actually is to erosion. So unfortunately, some cliff faces are incredibly susceptible to erosion due to a weak geology. Now, what I want you to have a go at is just pause the video here, and you can put these statements into order as they actually occur. Now, what you'll notice here then is the weather will be weakening the rock structure, whether through a freeze-thaw or salt weathering. The sea then attacks the base through abrasion, hydraulic action, causing the weakening and removal of the material. You've then got a little notch, a wave-cut notch, and a very heavy overhang of material above. Now, what will happen is over time, that material above the notch will weaken and eventually rockfall and be taken away by the sea. And then that will cause the whole retreat of the coastline. So this coastline is actually moving backwards. So it's very worthwhile having now a read through the textbook pages for any additional notes and having a go at the exam questions too. I look forward to seeing what you produce. If you could upload that to Teams for me, that would be smashing. Okay, take care guys, bye.